Hello and welcome to the channel. Today we're going to quickly dive into f-stops versus t-stops, and I'm going to tell you what's the difference between those. You've possibly heard both of them. One is more photography related, the other one is more cinematography related. So let's take a quick look at what this is all about. Let's go. The issue is there's the f number, then we have certainly the t number, and they most likely don't match. So what the heck is the t number and why is it different from the f number? So aperture and f-stops, so almost every camera lens has a mechanical diaphragm inside, and it can be opened or closed to let more or less light through. That is basically what the aperture is, and is referred using the term f numbers or f-stops. So a large opening in this regard lets in more light than a small one. So the smaller the f number or the stop, the bigger the opening. So here's a small graphic for reference, and yeah, just to give you a little bit of imagination how that's gonna look. The f numbers are the f stops, it's the same thing. So yeah, in photography and video, a stop is basically a step that either doubles incoming light or cuts it in half. So knowing what numbers represent what stops is very, very important to figure out how much light is coming through and eventually reaches your sensor on film. I've switched between the colors, as you see here. So there might be stops in between in your camera, but that might be thirds then. So these are the officials from 1.4 to 2.8 to 5.6. It's also always the double or the half, as well as from 2 to 4 to 8 to 16, 32, 64, 128, and in between. So there we are doubling and halving. If you have anything in between in the camera, it's the thirds in between. So that's just setting base, but we talk about full stops on what you see here. Anyway, stops, same number, different story. So just because a lens has a similar f-stop doesn't mean really that it lets in the same amount of light, okay? So for example, a 50mm 1.4 from Canon will probably let in a different amount of light compared to a 50mm from 1.4 from Sigma, even though they have the same numbers. So this is caused by light transmission through the lens. So due to the glass element, it is impossible for a lens to allow for 100% of light to pass through it. So most lenses allow for 60 to 90% of the light to pass actually through the lens. So nicer and therefore most likely more expensive models typically allow for more light to pass through the lens than a cheaper one. So how do you know? How are you supposed to know how much light is actually going through your lens? Filmmakers in early Hollywood answered this question by coming up with t-stops or transmission stops. So t-stops are a measurement of how much light is actually going through the lens at any given f-stop. T-stops take into account the percentage of light that comes through the lens and mixes it with the f-stop, if you will, so to speak, to simplify it a bit. So for example, a 100mm lens at the f.2 with a light transmittance of 75% will have a t-stop of 2.3. Well, that's a lot of numbers in a very short amount of time, just trying to simplify it a bit. Now, similar to f-stops, the greater the t-stop number, the darker the image. So generally speaking, t-stops are used much more in the filmmaking industry than in the photography world. Nevertheless, it can get confusing because it's not the same. So summarized, photographic lenses are normally measured in f-stop, so while cinema lenses are normally measured in t. So basically the f-stop is a measurement of the opening of the lens, the t-stop is how much light makes it to the sensor if you want so. As light passes through the lens, there's always loss, never gain, so that's really important to remember. So t-stop is always slower, yeah, we're talking speed here, so always slower than an f-stop. So for example, an f2.8 lens could be a t3.2. And another f2.8 lens can have a t-stop of 3.4. So a t-stop is, if you want, so the combination of both the f-stop and the light transmittance value of a lens. There is a mathematical formula behind it, and the t-stop can be calculated by the f-stop divided the f-stop value divided by the square root of the lens transmittance. This is how you actually get mathematically to the t-stop of a lens. don't have to do that. Usually the lenses are marked or, you don't have to do the math on your own, but there's always math behind it. So that's basically it for f-stops and t-stops and the difference between those. I hope this video answered all your questions. If you have any questions left, feel free to comment in the comment section below. And yeah, if you like the video, consider liking and subscribing. Would be really helpful to grow this channel. And yeah, stay tuned for new lectures, free lectures every week here on the Sundays. Bye bye.